Hello everyone, welcome to another video in my DC20 math series. Today I'm going to be talking about the idea of expected value. But first, I actually wanted to talk about a concept from the last video on advantage, and I want to talk a little bit about the idea of crit chances with advantage. I had some people ask me about this in the comments, so I thought I'd spend a little bit of time talking about this at the start of this video. So if we wanted to talk about crit chances, we need to talk about these equations we used from the last video to get the disadvantage chance, the regular hit chance, and the advantage chance. And really in here, rather than talking about an attack and a defense, what we're going to do is we're going to replace the attack and the defense with the fact that we want to get a 20. So it would be 21 minus 20 or 21 minus 20 in all of these sections where it's 21 plus the attack minus the defense. And so I've worked out a bunch of the math here because I know some people just want the numbers. So here's my page with the numbers. So the regular chance to get a crit or a crit fail is 0.05 or 5%. I've included both the chance in a decimal form and in percent here, so you can pick whichever one you like to look at more. I'll probably just talk about it in percents because most people feel comfortable with percents. So if you have disadvantage, you get a 0.25 chance to roll a crit with disadvantage, which is very low, right? And as we get some more levels of disadvantage, it gets more and more difficult to get a nat 20, right? In fact, looking at disadvantage 3, there is a 0.000625% chance that you're going to get a crit, which basically means you're not going to get that crit. It could happen, but statistically, that's incredibly improbable. On the other hand, though, advantage with the nat 20 shows you how likely you are to get a crit. And obviously, people can assume that if you roll more dice, you're more likely to get a crit, but here's how it works out. With one advantage, you have a 9.75% chance to get a crit. So it's almost double the 5%, right? But it's a little bit lower than that. So you're not doubling your crit chance, but it's almost there. The advantage 2 is 14.26. This value is rounded. It's actually 14.265, I believe. And advantage 3 is a 0.1855 or an 18.55% chance. So as a rule of thumb, you can kind of think about as you get greater levels of advantage, you're basically doubling, tripling, or quadrupling your crit chance. But it is always a little bit lower than that. And the greater levels of advantage you have, there's sort of diminishing returns there. If I have advantage 100, it does not give me 500% chance to crit, right? This is just a rule of thumb you can use, and it works better the lower your advantage is. So, it's a good way to think about it. Oh, if I'm rolling 2 dice, then that's like doubling the crit chance. If I'm rolling 3 dice, it's like tripling the crit chance. It's technically going to give you a sort of higher number than it really is, but it's a good way to work with it. And we can see that actually the same logic applies for rolling a nat 1, though the chances to roll a nat 1 for disadvantage are the same as the chances for rolling a nat 20 in advantage. And the same is flipped for advantage and with a nat 1. Trying to get a nat 1 with advantage is just about the same as trying to get a nat 20 with disadvantage. So there's a really nice symmetry in that sense. You can basically think about disadvantage as making you much more likely to roll a nat 1 and very unlikely to roll a nat 20, and the opposite is true. Advantage makes you very likely to roll a nat 20 and very unlikely to roll a nat 1. Okay, so let's talk about the real topic of today, which is expected values. So what do I really mean by this? Well, when you're rolling a d20, you're expecting some number to come out. And intuitively, if I asked you, if I roll a d20 100 times, and I averaged out all those results, what do you think I'd get? And most people are probably going to give me the answer of 10, right? Because if you're rolling a d20, right, I'm going to get everything from 1 to 20. I'm going to get some mix of those numbers. And so I should expect that the overall result is probably somewhere in the middle, right? And in fact, that's good intuition, but 10 is not the right answer. So here's how we can go about figuring this out. First, we take the chance to roll each of these, which for a regular roll, just roll one die. Well, then you're going to have a 0.05 or 5% chance to roll each one of these. So a 5% chance to roll a 1, a 5% chance to roll a 2, etc., etc. Right? And what we do is we add up all of those chances, right? So my expected value, right, is going to be 0.05 times 1 plus 0.05 times 2 plus 0.05 times 3, etc., all the way until we get 0.05 times 20, right? I wrote it all out, but it looks like a mess like this. And really, it's just 0.05 times the first number plus 0.05 times the second number And what we can do here is we can actually pull out that 0.05, right? We can imagine putting the 0.05 in parentheses in front of this, and we're going to get 0.05 times 1 plus 2 plus 3 plus 4 plus 5, etc., until we add up all the numbers between 1 and 20. And we'll get 0.05 times 210, which gives us an expected value of 10.5, right? In fact, if we had a die, right, we could roll that had 0 through 20, the expected value of that would be a 10, right? But instead, we have a die that has a 1 and a 20, right? So we can't really roll a 0, right? And so the expected value here is going to be sort of basically 21 divided by 2, right? There's a lot of ways we can think about how the expected value is represented, but let's talk about this generic idea, right? So in this case, if I roll a d20, I'm expecting on average it's going to be a 10.5. It's obviously going to vary a lot, but on average, if I rolled 100, 1,000, a million d20s, right, and I looked at what the results were for each ones and I averaged out what all those results were, I should get about 10.5. So if we wanted to expand this logic, we could think about this with the average of rolling a die with n number of sides without advantage or disadvantage, just a regular roll. And in this case, we take n, the number of sides, we divide it by 2, and then we add 0.5 to that. So you roll a d4, there's 4 sides, so it's 4 divided by 2, which is 2, and then we add 0.5, so 2.5. We got a d6, half of 6 is 3, slap a 0.5 on the end of that. Got an 8, half of 8 is 4, add a 0.5 on that, right? And this logic applies for any of the dice that we're rolling. So from d4, d6, d8, all the way to d20, we can see the average results, right? One important one to keep in mind here is both the d20, which we talked about before, that's 10.5, and the d8. D8s are pretty important in DC20 because we're talking about them in the context of a help die. And a lot of times you want to think about, well, on average, how beneficial is a help die, right? And we'll get into help dice math probably in a later video. It's actually quite a nuanced and complicated topic if you really want to do it mathematically properly. But for now, we can ballpark it. We can say, well, if I'm adding a d8, that's about the same as adding a 4.5 to my roll. So you could, if you wanted to lowball it, you could say, well, that's about adding a +4. Or if you wanted to kind of be a little bit generous, you could say that's like adding a +5 to your roll. So that's where you can think about a d8. A d8 is kind of like adding a +4 or a +5 to your roll. Okay, so what about rolling a number with disadvantage? So in this case, we're working off these equations with the last video, but instead of kind of doing the 21 plus attack minus defense, I'm going to use the letter V to talk about the chance to roll a number V, right, a value V, or to roll above that value, right? I'm not using n for number because I used n for sides before, but you could use n for number if you want here. And so we're using these equations for disadvantage, and basically the important part is, right, if I want the chance to roll above a value, well, that's basically what we calculated in the previous video, right? That's, go watch my previous video on advantage if you haven't watched it. That's what that's talking about, right? But if I want the chance to roll exactly a certain number, well, then I don't just want that answer from above, because I also don't want to roll above that number, right? So if I want to know what my chances to roll a 17, well, I don't want to know what the chances are to roll an 18 and a 19 and a 20 included in that. I just want to know my chance to roll a 17. So I take my chance to roll above a 17, which is this first little bit, right? That 21 minus v over 20 to the power of x plus 1, right? Where x is the number of advantage I have. And I'm going to subtract from that my chance to roll an 18 or above, right? So I'm saying, okay, well, what's the chance I roll a 17 or above, but not an 18 or above? And that's basically just saying, what's my chance to roll a 17? And we can apply the same logic for our chance to roll above that, right? We can kind of change the math here, and we can see in the second part, I'm saying 21 minus v plus 1. I'm just going to add that plus 1 to the 21, and I'm just going to write it as 22 minus v, right? Okay. So with advantage, there's this chance to roll above a value v, which is 1 minus 21 minus v over 20 to the power of x plus 1, right? It looks really messy. In fact, we're doing the same thing we did for the disadvantage, right? We take that chance and we subtract from it the chance to roll a number 1 higher, right, or above. It looks like a huge mess, but we can actually kind of simplify this out, because really what I'm doing is when I'm subtracting these, this 1 minus, the big whole bit in parentheses in front of both of them cancels out. And so what we get is this 1 minus 21 minus v over 20 plus 1 minus 22 minus v over 20, right? And so we can use these equations right at the bottom basically to figure out what our chances are to roll a certain value with advantage or with disadvantage. One little correction here, I actually forgot. You can see, I'll give you a second if you want to pause the video. I did make a math mistake here. The chance to roll the value at the bottom, actually, that first term should have a negative in front of it. So it should be negative 1 minus 21 minus v over 20, yada, yada, right? Because in this first bit, we're not actually getting rid of that one minus bit. We're only getting rid of the 1. We still have negative 1 minus 21 over v, etc., right? Okay, so let's talk about the expected value with advantage or disadvantage, right? I've worked out the math for these because it basically involves doing this for every single number and then multiplying it to that number, right? And then adding them all up, which is very tedious, honestly. And most of the time, you're not going to want that level of detail. The game mainly works from disadvantage 3 to advantage 3 in the first place. So let's talk about that. So what's the average value when rolling a d20 with advantage or disadvantage? So remember, our regular average value or expected value is 10.5. If I have disadvantage, the expected value is 7.175. If I have disadvantage 2, it's 5.513. I'm rounding the values a little bit here. And disadvantage 3 is 4.517. In red here, I've shown the amount that the expected value is decreasing. So you're losing about 3.325 on the dice when you're rolling with disadvantage. You're rolling about 4.987 from the value of the dice when you're rolling with disadvantage 2 compared to a regular roll. And you're rolling about, and you're losing about 5.983 from the expected value when you're rolling with disadvantage 3 compared to the regular roll. With the advantage, on the other hand, we have the advantage is equal to 13.825. So the average value of rolling 2 dice is going to give you about 13.825. That's an increase of 3.325. And you can actually see something nice here, which is that it's very symmetrical, right? The benefit we gain from advantage is actually the same drawback that you would get from disadvantage. The expected value gets changed in the same way, both directions. So advantage 2 is 15.488 against, this is kind of rounded here, and advantage 3 is 16.483. So what we're going to see here is that advantage and disadvantage basically work to buff and debuff your rolls. And this is where I wanted to actually talk about the nuance to this and tie this into DC20, because oftentimes there's a question you can ask, which is, am I better off getting advantage or am I better off getting help die? Now, obviously, both is the best scenario, and there is some nuance, which is that advantage makes you better at not rolling a nat 1, and it makes you better at rolling a crit. But a help die overall gives you a plus 4.5 to your roll, which is better on average than getting advantage. But it's worse on average than getting advantage 2 compared to a regular roll. Now, normally you don't have the choice between, do I want to get advantage 2 and do I want to get help? So what this means is that most of the time, getting a help die is going to be better than getting advantage. But obviously, they both work very well together and they both synergize with each other, right? At advantage makes your rolls more consistent, whereas help die just increase the maximum potential value of your roll and kind of also increase the minimum potential value of the roll. Right? They don't really affect your crit chances at all. Okay, and that really sums up everything I wanted to go over with expected value. I wanted to keep it short today with a nice kind of clean video talking about some of these ideas of expected value and mainly just providing these numbers since I saw a lot of people asking these questions in the comments of my previous video. As always, thank you for watching, and until the next time, have the best time.